people make a big deal about it, and all I'm really going to ask you to do is to justify what you do. That's really all a proof is. Oh, Mariah, you sure? Okay. All right, so proofs, really simple. You have two-column format. I really don't like the two-column format, and yeah, so we're gonna do them in class, but when we do other things where proofs are involved, paragraph proof works way better. But this is just unfortunately one of the things that I have to teach you guys how to do. All right, so we're looking at beginning proofs, two columns. The first column was for statements, and that's where you literally list your steps. And when you guys look at the two problems that are modeled on the side of the board, you can see where they actually added 30 or added 47. We don't do those in proofs. We only list the steps. So you're somewhat showing your work, but you're really not. And then the other side, the right side of that two column, is where you list your justification. You list your reasoning. So it's basically what you guys had to do for homework. And when we look on the left side of the board over here to what Madison did earlier, she pretty much has the format for the proof already done. The only difference is she just needs to switch what her steps are and what her reasoning is. And that is literally a proof. It's simple as that. Now, I know a lot of you guys are like, man, I hate proofs, I don't get it. But here's the issue. What you need to ask yourself is what changed and why is this step correct? If you're asking yourself those two questions all the time, what changed from that step to this step, and why is that step correct? Why is it okay for me to do that? The proofs are not that bad. So let's take a look at this through an algebraic process. We're going to solve this problem. 2x minus 7 equals 1/3 x minus 2. And when you're doing proofs, you're always going to be given information. That is your starting point. That is your assumed truth, right? Yeah, right. Those are your given. So we're given that equation. Here's the good news. Every single person in this classroom should always get at least one portion of a proof correct. And that's because the first line of any proof, of all proofs, is what? The original problem. Given. So you're always going to write out the given statement, and the reason why that is correct is because it is given to you. Therefore, that's your reason. That's the given. That's your given statement. Sure. Still good?
Why is standing still?
All right. Second step. What are we doing? We have not distributed yet. What have we actually done? What changed? Remember, that's that question you always need to answer. What changed from line 1 to line 2? We haven't added anything. We're multiplying by 3. And you don't need to say what you're multiplying by, we say it's the multiplication property. So I'm beginning to distribute. So now what changed from line 2 to line 3? Now we've done the distribution. So that's your distributive property. All right, what did I do on the next line? Tiffany? What do you mean? All right, so that's going to be the subtraction property.
Oh, so you're not really writing anything down, you're just writing the property.
Just the property that's taking place. What's the next line? What did we do to go from here to here?
Ooh, I know. Isn't it?
Yeah. So we added. And then my last step is division. Hey, are proofs really that scary?
Yeah.
No!
Not yet.
Alright, I want you guys to do this one. If you need to move, then move. But I want everybody doing this. Alright, so let's go back to here. Alright, first line of any proof is always given. Now guys, what is I want to point out to you? Is notice your first line is always the given. What's your last line of any proof? No. It's your proof statement. So anytime you're asked to do a proof, you're going to be given a statement, and then you're asked to prove something else. So the last line of that proof is always going to be the proof statement. But the reason for that is wide open at this moment.
So wait, we don't actually put proof.
No. The word proof will never be used as a reason. Alright, so what's our second step? What are we doing there? Yeah, we're multiplying by 3. Okay, what about my third step? Same?
Distributed.
That's the distributive. Dylan?
Subtraction.
That's subtraction. You can have addition, or you can do the additive inverse. That works for it as well. And finally, my last step is division. Zane?
These aren't always going to be the same order.
What do you mean in the same way?
Like, say one has the same order.
Oh, no. Not always. Alright guys, that's basically what proofs are. Are they really that bad? Okay, well we'll discuss that more on Thursday. So, right now, we're going to practice this. Now,